Voilà, donc j'arrive juste à temps, visiblement. Je suis ravi d'être là parmi vous. Je regarde un peu qui sont les gens dans la salle. Vous êtes tous, pour que je connaisse un petit peu mon public. Oh, sorry. Of course. So I was saying that I'm very happy to be here, and I wanted to discover a little bit who are the people in the room. So who is, let's say, a researcher? I know one. And who is in education? No one? So mostly researchers. Okay. So I'm going to present very quickly today a new part of Aldebaran called the A Lab, for Aldebaran Lab, which is a research entity within Aldebaran. So very quickly, in fact, this research entity that has just been created is divided into two parts. One is applied research, and one is a bit more unusual, I would say, for a company of the size of Aldebaran, which is fundamental research. So I'm going to quickly go through these four labs, describing you what the kind of things are done in this domain, and I'm going to detail a little bit more this last part, which is my specialty and which I'm going to more directly manage, and which is about artificial intelligence. So the first thing is the Mechatronics lab, where we are going to work on, and we are already starting to work on things like this robot. Mainly we are looking at interesting problems related to new actuators, new way of making robots. If you look at robots in the world today, most of them are using, I would say, traditional motors, control in position, this kind of technologies. And we believe, and a lot of people also believe, that there are a lot of things that can be done in improving the type of control and the type of actuators that we can put in robots, in particular, for example, force control type of actuators. So a lot of research will be done, and has already started with a project that you can see here called Romeo, which is now Romeo 2, the second part of the project, where we explore new actuators. We also look at new sensors to go with these actuators. If you actuate differently, you need to sense differently. And of course, new control algorithms that goes together with this new actuators. So a vast area of research, which is to go beyond the traditional position control robot, maybe one day towards robots like with actuators more like muscles or things like that. Everything is open, and we're looking at new ways to control the robots, make them more flexible and also more safe to interact with. The second part is, in fact, closely linked, is the dynamics lab, where we're going to look at walk algorithms. So once we have this control, either the existing one or the new one, we have to look at how to make them work together to generate walks. There are questions on grasping. More generally, if you look at dynamics as also movement, we also work on navigation using visual landmarks, so visual slants, these kind of things. And very important also self-calibration. We want the robot to build dynamically a model of his own body so that it can, adapt to whatever goes in his life in terms of changes. The third lab is the interaction lab, anything related with this super important domain of robotics, which is interaction, everything that goes with the human-robot interaction domain. So audio-video processing, of course, new sensors also, but for vision, Kinect and these kind of things. We can go much further than that, we believe. So there are a lot of room to explore new ways of sensing the visual environment and the 3D environment. A lot of work on the dialogue engine, which in fact is the cornerstone of the human-robot interaction. We believe that it's the most important thing. So a lot of things have been done in this domain recently through Siri or Google initiatives to get people to speak with their smartphone. So we can use these kind of things, but we have to go beyond, because the robot is more interactive than a smartphone, so there are a lot of things that needs to be improved, and a lot of things that we can take advantage of in terms of information processing, not only sound but also visual information. And together with that goes, of course, research in machine learning and deep learning, so unsupervised learning, whatever we can extract from the environment to enhance the interaction and learn what the user is expecting from the robot. The fourth initiative is the System Lab, where we look at more traditional engineering questions like system safety, how can we build programs or architectures, middlewares that are safe in the sense that we can guarantee to a certain extent in terms of security for the user. We keep working also on Irby. So this Irby is a domain-specific language that I created almost 10 years ago, and which was the topic of my previous company, Ghostai, that has been acquired by Aldebaran. So we keep working on this language. Very shortly, Irby is a domain-specific language for robotics that implements parallelism or event-based programming within the semantic of the language. So with that, there are a lot of nice things that come, and we want to go further in this direction. And also this System Lab will concentrate a lot of things related to integration efforts, which is a super big topic, of course, when you're trying to put everything together in a robot. And finally, the AI Lab, which is not very original in its name, Artificial Intelligence Lab. I don't know how many AI labs there are in the world, but probably a lot. What is particular is that it's fundamental research. So the people, there will be 5 people, so there was 5 open positions, there's only 4 now, but they are still open. We're looking for young or senior researchers interested in research in this domain that I'm going to develop in a second. So it's a relatively small, but comparatively with the size of the company, quite big effort into fundamental research. So we look at science and hard scientific questions related to, well, we cannot look at everything, so we are interested in a domain called Developmental Robotics, which is basically looking at the problem of artificial intelligence from the standpoint of learning, and learning, I would say, like a baby. So trying to learn everything, learning your body, learning information about space around you, and then slowly going up to learning language, learning grammar, learning motor skills, and everything from the ground up to the most abstract skills. So this is the broad research program, and to look a little bit more in detail about that, there are actually 5 people, so there are 5 areas of research. What you're seeing here, there are 2 more here that I'm going to disclose in a second, so it's a bit of suspense. But so what I want to say is that these 5 areas are not so clearly cut. They are just domains where we want to put efforts, and the boundaries are not so clear as this slide seems to show. There are, in fact, on this slide, the 3 very classical, usual issues of AI, which are mostly symbolic processing. So here we are more interested in the emergence of language. So we're concerned about emergence of grammar, emergence of lexicon, and having these things dynamically emerge between a population of agents. So we hope to have something like meaning emerging from the dynamics of these interactions. I will come back on that in a second. And on this side, you have the more traditional perception level, where you extract information from the fluid sensors that are not easily transformable into symbols, and you try to make sense of it. But the difficult, very difficult questions, which is sometimes called, as you know, the grounding problem, that has been positioned by Arnad in 1990, is how to connect these 2 worlds. You have a lot of very interesting experiments done on language evolution, for example, by Luc Steels or Pierre Voudeillet or this school, that is showing that you can do some dynamic interaction between robots that leads to the emergence of a language. But in these experiments, rightfully, because the point was to show that this dynamics was going to work, I mean, everything is put by hand by the researcher in the system. The categories, the visual categories, for example, that the robots are talking about, are extracted by a predetermined algorithm. The type of interaction that the robots are engaged into, which are called, for example, in that case, they are called language games. So these kind of very structured interactions are also predetermined and carefully constructed, in fact, by the researchers to demonstrate that you have a convergence of the dynamics, etc. But this, if you are in a purely developmental approach, you have to justify where it comes from. It cannot come from the mind of the engineer. It has to come from a more fundamental principle. On the other side here, you have very, very interesting things on extracting in an unsupervised way regularities, correlations from signal, and trying to group them into meaningful structures. So this goes into the unsupervised, non-active learning, where you get information and you try to structure it. You recognize some keywords that are very popular now in the community on this topic: deep learning, slow feature analysis, etc. And you have here one layer on top of that, which is also unsupervised learning but active. So we imagine the robot actively performing things in the environment to facilitate the acquisition of meaningful categories. But at this stage, you still have, well, and you have all these interesting ideas on intrinsic motivation and how the robot is going to be driven to actually look at certain types of information and certain type of learning in the environment. But at this stage, you still have a lot of categories that are candidates to become grounded categories, things that you are, to be very simplifying things that you are going to be talking about. The way I could categorize everything I see here is absolutely gigantic, and I could categorize these things quite legitimately in terms of correlation and stability in time, etc. So on one side, you have very interesting dynamics of language games that converge to shared languages, but with fixed categories. On this side, you have interesting emergence of categories, but there are so many, you don't know which one is important. So the idea is to connect those two things and have two areas of research that basically revolve around grounding not only the lexicon and the grammar, but also grounding the interactions themselves. So having some fundamental principles, something very elementary, a bit like intrinsic motivation, which is, as you know, dealing with the increase of the rate of learning of the agent. Something like that, something very fundamental that would lead to the emergence of a certain type of interaction between the agents that is or share properties common with the language games, so that you have the emergence of this lexicon and grammar. So this, I divide it into two main areas. There are probably 3, 4, 5, and it's very fluid. It's still something we are, in fact, thinking about. I don't have any answer for these difficult questions, of course. So, the first part is, I think, very important, is theory of mind. As soon as you try to look into grounding interaction, you have problems like turn-taking, deciding what the other is intending to do, building joint attentional scenes, all those things that have been very well described by Tomasello or other developmental psychologists. So you have to somehow have a model of the other inside your mind. So this is theory of mind, and I think that we can start also or help in this process of building theory of mind using emotion. Using emotions as a non-verbal, very elementary set of clues that you could use to structure proto-interactions, and that's what you see with young babies, to build the first layers of this theory of mind. So we're going to work on this, emotion modeling, emission and recognition of emotions, in the perspective of theory of mind. And finally, this big question, it's more like a huge question mark, is how do we build on top of that to construct these language games dynamically, so that the agents are going to engage into structure interactions which probably have something like a success or failure at the end that will lead to the emergence of lexicon and grammar, taking inspiration from experiments like maybe, you know, talking heads or this kind of experiments that have been done, which are very convincing on the fact that it's meaningful and interesting to have a dynamics. It's actually a selective dynamics that selects certain types of structure. I don't have time to go into details, but so to have this kind of dynamics that goes, build a shared grounded lexicon or shared grounded grammar that helps the agent to communicate. So if we, and I'll conclude on this slide on that, if we come back on the first problem, which is here, we have too many categories, too many potential categories. And here, well, we have a nice dynamics, but we don't know what to plug inside this dynamics. The idea is that the link could be the success of communication. Interesting categories that the system will ground, will actually embed into their ontologies, I would say, are going to be categories that are useful to communicate. And at some point, some categories are, for example, I don't have a category to describe, you don't see that, but I mean, this grid here, it's complicated pattern of texture. I don't have a category for that because it's too rare. And if I bother to create a word for that, I'm not going to be very successful in communicating with it. So this is a criteria that is interesting to look at why we use certain words, how we structure the world to ground these symbols that have been so elusive so far. One last point is a bit transversal to everything. Something I would like to start, I don't know if it's going to work, but the idea is that there's a huge literature in developmental psychology describing what babies are capable to do at certain ages. For example, when they, a very classical example, when do they start to understand, and when they don't see an object, the object is still there. And a lot of things related to cognition, spatial cognition, temporal cognition, or language acquisition. And it's very hard. I'm starting to look at those things, I mean, for now a few years, but I'm still starting. It's very hard to know what is the state of the art, and to be more realistic, I mean, what are the controversies? What are the topics? And when you read something in an article, sometimes the author are giving the opinion of others, sometimes they can't because the opinion has not been written at the time when the article was written. I mean, you see the problem. And the idea is to maybe start a kind of Wikipedia type of thing, where anyone can put, let's say, a fact about child development that must be backed with a peer-reviewed article. So we don't, it's not like, you know, you express your opinion. You have to have an existing article that has been properly reviewed. And you can put this fact, and there is a discussion area where people can say, no, I disagree, again, with a reference. It's not about saying what you like. Or maybe there will be a section for people to express their anger or something. But the idea is to have a central place where you can have all the state of the art. For example, I'm personally interested in knowing everything about the pointing gesture, which is this very typical thing that Homo sapiens is doing. Well, there is a lot of things. You can go on Google, etc. But it would be very nice to have some central place where all the knowledge we have acquired on developmental psychology could be stored. I don't know if it's going to work, but we are going to start, if only for ourselves, to have a central place. And maybe if you want to contribute, of course, you will be more than welcome, and maybe it will become something useful for everyone. The last point is we are going to start, so it has nothing to do with the research program, but we are going to start a set of events called the A Talks, where we are going to invite prominent researchers in AI, robotics, or very connected topics, like, for example, developmental psychology, to give a 30-minute talk, and we are going to put those things on the internet and make them available, a bit like TED Talks or Google Tech Talks, these kind of things, but focused on robotics and AI. So hopefully this will be interesting for people who want to know, not only experts, but general public, not only beginning, I mean, it will be kind of good level talks, but in between experts and people who have no clue. And I think it will be very interesting to gather all this knowledge. So we'll see. It will start in September 2013, and we have already a list of people who are going to talk. More to come soon. There will be a website. And I think that's all for the moment. Thank you very much.